So I'm with Grayson from Penn Electric, UPenn's Formula SAE EV team.
EV, yes.
How are you doing today?
Good. I'm doing well. How are you?
Good. So we're here. It's a Saturday. You guys in here every Saturday?
Every single Saturday, 10 a.m. sharp.
10 a.m. sharp. How late do you go?
A lot of the most dedicated members stay to about 6 or 7, but
Okay.
really in this really critical manufacturing season, we try to stay even later, or pretty much however long it's required. We always say it's important that our members leave, not at a set time, but when the job is done.
Okay, I like that. And you said the dedicated members. What about the undedicated members?
It's very critical to have all the members of the team working towards the same goal and pulling in the same direction all the time. Now,
Yeah.
I say the most dedicated members,
sorry.
but all the members of our team are
Yes.
very dedicated. Are very dedicated to the team. We've got people who are almost everybody who's dedicating a majority of their Saturday to making the race car a reality.
Absolutely. That's how you win all those trophies, right?
Exactly.
There
Yeah.
you go.
Well, that's what we used to motivate the team for this year, at least.
What stage in the process is your team in right now in the build?
Right. So we just started. We run a design cycle where the first semester of the year is pretty much all design. We finalize the design right at the end of the first semester, and then we jump right into manufacturing right in the second semester. And even before the second semester starts, we have a lot of, again, the most dedicated members of the team who come back multiple weeks early before the semester starts just to work on the car for multiple weeks. So and then after the semester starts, we've been in manufacturing for about 4 weeks during the semester now, and we have the reveal of our car to the whole school and our engineering department and our sponsors in about 6 weeks. So we are in short, we are right in the heat of manufacturing right now.
All right, you're in the middle of it. So do you manufacture it here in this workshop or somewhere else?
Yes. So this shop right here, B11, is Penn Electric Racing's main build space. This is where all of our assembly happens. A lot of our design work happens. A lot of our aero manufacturing. And just the rest of the assembly, and then we also have the PML, the precision machine shop in our school, which is where we do a lot of the rest of the machining and the manufacturing for the car.
All right, and then what's going on behind us?
What's going on behind us is our team's electrical team's main space. So our team actually custom designs the entire electrical system of the car, and we're one of the only North American teams to do so, which is really cool and really exciting. But it takes a lot of very dedicated members on the electrical team to do so. So this half of the space is mainly used by that electrical team for the debugging and the assembly and the software of all of our custom boards on the car.
All right, and then where do you test all this stuff? Like, do you wait until the car is built and test and then go in and fix it? Or is there testing you can do throughout the build?
Yeah, so there's testing that you can do just with the boards, with the boards individually. But one of the most important deadlines that we have for the team that is actually coming up right at the end of next week is our electrical handover deadline. Okay. This is where the mechanical team will have all of the wheels rolling critical parts in the car done and on the car, so we're able to hand the car over to the electrical team, so all of the boards in the electrical system and the wiring harness can be integrated with the car, and then they finally get the car ready to drive before our unveiling.
Okay, great. And then are you the one who keeps everybody together? Are you running this or no?
Well, so I'm one of the mechanical co-leads for the team. So my primary responsibility is a lot of running the show from the mechanical side, ensuring that all the parts, all the different assemblies are on schedule, both in terms of design and manufacturing, as well as setting the overall larger team goals and direction.
Okay, great. So everything's going smooth. You're going to hit that deadline, and you'll be ready to hand off to the electric team?
It'll be close.
Okay.
It'll certainly be close. Again, we've had a lot of really dedicated members on both the mechanical and the electrical team working tirelessly this entire semester to hit that deadline. There are a couple components of the car that are may slip a day or two behind, but I'm overall very confident that we're going to get a vast majority of the car ready and handed off to the electrical team next week.
That's awesome. And then before we started filming, you were talking about how you guys went from a solar car right into an EV car.
Yeah.
And you were one of the first EV cars, right?
We were.
And then now you teach or help other schools with their EV?
Yeah. So, yeah, as you mentioned, we back in the 2014-2015 season, the team built the first our team's first car, Rev Zero, which was one of America's first EV FSAE cars. The next year we followed that up with Rev One, which won the FSAE competition and was North America's first driving car. And we've only continued to build on that success since. And now these days, where a lot of the combustion teams are looking to transition to an EV car, we've tried to provide as much support to other teams as possible. We actually just yesterday in our shop, we held a workshop for another local combustion team that's looking to make the transition to EV in the next couple of years.
All right. And when they succeed as an EV team, do you take a little bit of credit of that, or you want to give it all to them?
I wouldn't say credit. I mean, of course, all the credit belongs to the team and the really dedicated members who made that project a reality. But it certainly feels good to kind of give back as much as is possible, because at the end of the day, this is a race car competition, but we're really all working together to build the next generation of engineers for this country.
Yeah, absolutely. And it's kind of nice to have some good competition, right?
Absolutely. I mean, it wouldn't be fun if we were just able to drive off into the distance. We want as many cars driving and competitive at competition as is possible.
Absolutely. And then you never had an IC team.
Yeah.
Was that a conscious decision, or was this before your time?
Well, this was long before my time. I think I was I think I would have been in middle school.
How old are you, real quick?
I'm 22.
Okay.
I'm 22.
Get out of here.
Well, how old are you?
How old do you think I am?
Oh, tough question. 28.
Okay, I'm 29. I'll
All
take
right,
it.
Pretty close. All right. But yeah, University of Pennsylvania never actually had a combustion FSAE team. We had a solar car team, which I don't know if the camera can catch that, but that poster right there is kind of the start of our team's history. But in those days, a couple members of the team decided that they wanted more, and that they wanted to make the jump into building electric vehicles, which even by that time they recognized was the future. Mm-hmm. So a couple, approximately 10 or 15 really dedicated members put in the time to take that it takes to build our first car, Rev Zero, and our second car, Rev One, and Rev Two, and become North America's first driving EV FSAE team. But to answer your question, no, we were never one of the teams to make that jump from combustion.
Before we get into the other questions, if I'm let's say a high school senior, and I'm looking to build a race car, why should I come here to build an EV car with you guys?
You should come to the University of Pennsylvania and join Penn Electric Racing, because you of course will get a lot of really good experience in engineering and building electric vehicles, whether you want to do mechanical engineering, electrical engineering, or whatever else you want to study. We have a lot of members of the team that are neither mechanical, electrical, or CS or any sort of software. We've had biology majors on the team. We've had English majors on the team who are here for one purpose, like not necessarily because they love engineering and they love race cars, but because they love being a part of the most dedicated and passionate group of people that they've ever met. I can't promise that you'll win trophies. I can promise you that on this team we will do the absolute best to help you become the best engineer you can possibly be.
That's all you need, right?
Yeah, exactly.
I like that. And then, so biology students, what do they do on the team?
We actually have one biology student who designed the pedal box of the car this year. He had done FRC for many years in high school, and wanted to continue working on that, even as he continued his pre-med studies. And again, even though he's not necessarily learning those skills in his classes, we at Penn Electric Racing try to do our best to go above and beyond to teach you all the skills that you need to succeed on this team.
Yeah, and then you did say you spend most of your Saturdays here.
Right.
In general, how many hours a week are you in the workshop?
How many hours a week am I in the workshop?
Yeah.
That's a good question. In this really manufacturing
We're in the heat of it right now.
We are absolutely in the middle of the heat of it.
Yeah.
I would say that I am doing probably 55 or 60 hours of this a week. It's not quite that much all year round, but again, the most dedicated members of our team are doing this not because it's work or because it feels like a 60-hour a week job, but because the time just flies when you're here.
Yeah.
You know, there's never enough time to meet all these deadlines that we've been talking about.
Right. And so you're working hard, and I assume you're making a lot of friends on this team, right?
I'd like to think so. I mean, they have to. All the members have to at least pretend to like me. But no, it's as I mentioned before, it's not just about the engineering and the race car and the trophies that motivate people to give it their all. That last little bit comes from the people, and it comes from the community, and it comes from working alongside a group of people who are just as dedicated and passionate as you are.
Absolutely. And so all the hours you spend here, does it affect your schoolwork, or do you make it work?
It seems a little bit overwhelming at first when you talk about, again, the number of hours that you might put into the team, as well as focusing on your schoolwork.
Yeah.
But because building a race car ultimately does not feel like that much work. It's fun. It isn't really a challenge at all to, you know, be doing what you need to do for school and putting in the time to make sure you're succeeding and learning from all your classes, while also coming and applying that knowledge here at the race team. I would actually say that my work on the race team has helped and improved the performance and learning that I've had in my classes, because all the knowledge from both goes hand in hand, and each supplements the other one.
Oh, that's good. So school is kind of the work part. This is just having fun building race cars with your friends.
Exactly. Now, because you're interested in joining the team, as you said,
right? As a high school senior,
to all the high school seniors who may be watching this, although we say it's not work and it's a lot of fun, it does take a lot of dedication and time and effort to make a race car a reality.
Right.
It takes a lot of really dedicated people going above and beyond. But the rewards that you get out of it, not just in terms of the trophies, but in terms of the knowledge that you gain as an engineer and the experience that you gain, and also the access to a lot of really, really cool internships and jobs, it pays off tenfold in the end.
So after college, after graduation, are you looking to go into a profession of building race cars?
That was certainly one of the things that I considered. One of the opportunities that I actually got because I was a member of this race team was the chance to go work for Aston Martin Formula 1 in a student placement role last year.
Awesome.
But it's not just people who are interested in working on race cars full time who really get a lot of this, who really get a lot out of the team. We send multiple people to SpaceX every year. We send people to Tesla, Rivian, Ford. I could list off 30 of the top engineering companies in the country, and there's probably a Penn Electric Racing member working there, as I'm sure is the case with a lot of other SAE teams.
That's awesome. What's a typical timeline for designing, manufacturing, and testing the car before competition?
How I went about setting the timeline for the car this year is essentially working backwards from competition. Okay. We know, of course, at competition we need to have a driving, reliable, and quick car. In order to do that, our team has found that approximately 2.5 months of car testing time is what is required to work out all the reliability issues, as well as provide our drivers enough practice to truly maximize the performance of the car. So we then set the date of April 1st for the car has to be ready to drive, and that's when we're going to go out and do our first testing session. Then we unveil the car to the school right before that. So essentially, we have a date of March 28th set for the car has to be completely ready to both present to the school and go out driving the next day. We typically spend about 2.5 months manufacturing all the mechanical systems of the car, as well as an extra month for the electrical team to integrate the wiring harness and the boards into the car and make the car drive. So that puts us right at the cutoff between the first and second semester as our design time and our manufacturing time. Okay. So that's typically the logic that we follow for our general overall timeline.
All right. And then where do you test your car?
We are very lucky to have the Philadelphia Sports Complex right by the Philly Stadium.
Okay.
We're able to rent out one of the parking lots and test the car there.
Oh, okay.
Of course, as an urban campus team, there are not a lot of large open parking lots around the area.
Yeah.
But just a 10-minute drive away, there's a sports complex that we can test in, and that is critical for us to be able to get the car up to speed and test safely.
That's awesome. And then where do you find your drivers? Are they just members of the team that are also good at driving, or do you seek them out?
We don't actively recruit drivers.
No.
We give everybody on the team who is like significantly contributed to the design and manufacturing of the car
No.
a chance to test out through go-karting if they're particularly keen on potentially becoming a driver.
Okay.
From there, we pick the fastest few and put them in the actual car during the first couple weeks of testing, and then from there we can decide who has shown the most speed in the car, essentially.
All right. And are you a driver at all?
I am. I am actually.
Okay.
Yeah. I'd like to think I'm pretty good, but we'll see.
Wait, we'll see in June, right?
We'll see in June. We'll see in June this year.
Or will you be driving in any particular event, or all of them?
Of course, drivers are limited to just two out of the four events in the FSAE competition. So I typically drive the autocross and endurance events, and then we have other dedicated members of our team driving the, as kind of my partner for the autocross and endurance, and then two others driving the acceleration and the skid pad events.
Okay, awesome. Hey, we'll be live streaming the EV competition this year. So.
There's a live stream. There's a live stream for this year.
So you'll be live on YouTube.
Live on camera. All right. Good to
keep
hear.
an eye out for Grayson coming in first, baby.
Fingers crossed. Fingers crossed.
Build it up, man. Build it up.
Well,
You're right. You don't want to oversell it. You're so humble.
I like to let the car do the talking on track.
Oh, I like that. I like that. So what were some of the biggest design challenges you faced this year?
So some of the biggest design challenges this year is this was actually our second year doing a custom planetary gearbox in our car. Now, that's one of the most complicated parts in the car. It's one of the most complicated projects that the team has ever taken on. Mm-hmm. So it was a really big design challenge to ensure that our gearbox was working at the maximum performance possible, and we didn't have any tolerancing issues or tolerancing stack-up issues or manufacturing issues that we had seen in the previous year, which was the first time that we had tried to do that gearbox. So that was one of them. The other design challenges this year was we wanted our differential to be outside the back of our chassis rather than enclosed in the rear box to save a lot of chassis mass.
Okay.
But actually changing the packaging to enable that was certainly a challenge, but it's one that absolutely paid off in the end with a massive weight reduction in our chassis.
Oh, awesome. What are the key aerodynamic elements of this year's car?
One of the biggest improvements that we've made to the aero system of our car this year is having a front wing main element that is one continuous layup across the entire front wing rather than multiple sections. Okay. This ensures that we are able to significantly increase the overall stiffness under load of our front wing, ensuring that it will not scrape or hit the ground at any points, or otherwise deflect that takes our actual aero package away from our simulated one. So there's been a lot of hard work from our aero team to pretty much overhaul the entire front wing of the car and also design the new pretty complex mold that actually allows that to happen. And we're of course extremely grateful to one of our team's very generous sponsors, Leading Edge Composites here in Coatesville, Pennsylvania, for helping us out with the actual manufacturing of that mold. Our aero system would not be a possibility without them.
All right. And then you mentioned simulation, right?
Yes.
Do you test the whole car in the simulation so you kind of have an idea of how it'll perform when you take it out in the parking lot for your first test drive?
Yeah. So in terms of aerodynamic simulation, with your previous question on aero, we use Star CCM to essentially we can optimize singular elements of the car in there, but most importantly, optimize the entire aero package overall.
Okay.
So we've run dozens and dozens, if not hundreds, of simulations in STAR this year to ensure that our aero package is at maximum performance under not just static conditions, but all our expected roll, pitch, squat cases as well. In terms of a full car simulation, our vehicle dynamics team has been working tirelessly this year to develop an all new quasi-static sim as well as a quasi-transient sim. That's one of the areas of our team that I am most excited and most impressed with this year is the leaps and bounds forward that we've made in terms of our vehicle dynamic capabilities. I'm very confident that our simulated lap times are going to be very close to what we experience, what the car is actually capable of.
Yeah.
And if that's true, I think we're going to be able to have a really quick car competition this year.
That's awesome. What's the craziest or most unexpected problem you had to solve throughout the build this year?
The craziest and most unexpected problem that we had to solve throughout build this year.
Or were you so prepared there were none?
Well, one thing that comes to mind is we did in-house welding for our primary accumulator this year for the first time, and when I welded up the whole thing, we had an excellent jig for it. I welded up the whole thing. I was careful to work around the different corners of the accumulator to not let the heat warp it too much.
Yeah.
But then I take the welded accumulator and I look at it, and it's the rectangle box is no longer a box. I'm like, oh no, the accumulator is warped. It's not going to work. With some pretty ingenious jigging of a couple of the flanges that we welded on, we were able to clamp it back down flat, weld those on, and lock it in place for the season.
Nice.
There's probably a little bit of residual stress in there right now, but nothing that's nothing that our FEA and analysis says that the primary cannot handle under SAE's rules, of course.
All right, perfect. So I'm with Rohan from Penn Electric. And you're the electric lead?
Yeah, I'm one of the 2 electrical hardware leads that we have, and then we also have 2 electrical software leads.
Okay, so we talked a little bit with Grayson about the electric build.
Yeah, so one of the things we love to do, it's a thing that we do that not a lot of the teams do, is we basically design our entire electrical system in-house ourselves. So we design all the PCBs and we make them ourselves, except for the ones that were required by rules to get to purchase from somebody else.
Yeah.
We really enjoy doing this, firstly because it's just really fun for us. One of our team's goals and missions is to create industry-ready engineers, and what better way to do that than to learn and design things yourself. The other thing we find is, when we make mistakes or when we're running into issues, when we design the things ourselves, it's a lot easier for us to debug the issues and try and figure it out because we understand the internals of the system and it's not just like a black box that we've never seen.
Yeah, absolutely. So you build it, your own other teams can or do buy it all, right?
Yeah. So many teams will purchase ECUs or like powertrain control units, and it's very common for teams to purchase their BMS systems as well. But we really enjoy making these in house.
And then, is it more or less expensive to build it on your own?
Yeah. So that's a really interesting question. I think in terms of cost, we found that it's generally comparable. It really depends year to year, depending on the parts costs, sponsorships that we get from companies, things like that. But we found it to be generally similar. One of the biggest places we have a lot of savings, for example, is in packaging and also in mass. So if you look at an off-the-shelf BMS system like Orion, which a lot of teams use, it's a great system. It has a lot of features. It has a lot of features that people don't end up needing, and it's quite a lot bigger than the packaging we have. And so what we really like is we kind of keep it to the features we require for our system, and we can package it in a way that's more convenient for us.
Oh, perfect.
Yeah.
How do you optimize power delivery for acceleration and efficiency?
Power delivery is a really complicated thing. mostly because of, I mean, I think a lot of teams see this. It's a very electromechanical problem. So you want to make sure that your electrical team is familiar with your goals and your mechanical team is. And so when we're looking about how to design our battery and our powertrain, we really get a lot of engineers from different areas together. We talk about the different design parameters and design criteria that we have. And then one of the really big things that we pride ourselves on a team is having a really good vehicle dynamics system. So we take past testing data and we run simulations. And we use that to optimize our design and pick a pack design and a powertrain design that really optimizes the performance for our needs and our design criteria.
You're the electric side, so are you waiting for the mechanical team to hand off the car to you to put in all the electric parts?
So it's, everyone kind of has a little bit of stuff going on at the same time. We try to make sure no one's ever, just sitting around doing nothing.
Right.
So, in the first part of the semester, the electrical team does all of our design work. So we're mostly in here, all filling all the computers and doing all the design work for the entire pretty much first semester.
Mm-hmm.
When the second semester comes around, you'll see in the background behind me a lot of people are soldering PCBs. We also are going to start in the next week working on our wiring harness, so there'll be a lot more of that. You'll see a lot of people also behind us designing PCBs. That's something actually new. We don't usually in the second semester have people designing PCBs, but we're working on a hardware in the loop system, which is basically a system that allows us to test our boards outside of the car as if they were on the car. And so that helps us validate our design better and make sure that we can catch errors earlier. This is the first year we're actually doing this, and so this year we're gonna try and get the boards working the way we normally do, and then we're going to use those working boards to validate our testing system. And then in the future, we'll be able to use that testing system more effectively and efficiently. And so a lot of our newer members are actually, who are all like first years, are actually working on designing these boards. And we feel it's a really good way for them to understand and learn about the car as a system, not just an individual board, and actually get experience, like hands-on experience designing PCBs.
That's great. And does that help when you guys graduate, the younger members can grow into those roles that since they grew up with them?
Exactly. That's a thing we really try and focus on. It really doesn't help anyone if like just the people who are upperclassmen know everything and then they graduate and nobody else really understands.
Yeah.
We really try to make sure that we are providing all the knowledge and information and access to that to our younger members. We do a lot of rookie lectures in their first semester, so we try and tell them about different parts of the car so they can learn about that. And then we really try and involve them with a lot of our debugging, our manufacturing, all the different processes and steps that we take.
All right. Yeah. And then are you also a driver?
I'm not a driver, no.
Okay.
So I don't think I would. It takes a lot of mental strength, I think, to drive the car. I would be too nervous to drive it, but...
It takes more mental strength than building the car?
I don't know. I wouldn't want to be in it. It's a pretty fast car, so...
Right. So what's the most rewarding part of working on an FSAE electric car?
The most rewarding part? I think, honestly, I think I'd say two things. I think the first thing is just that feeling when... I remember the first time I designed a PCB, it arrived and it was the first one that I designed myself, and I looked at it and we tested it and it did not work at all. But it was really, really exciting for the first time to see something that I'd come up with in my head come into the real world and into fruition. And then when I designed my next PCB, that one worked really well, and so I was really happy. But really seeing that, I think, was very, very exciting for me. I think the other really exciting thing was, when I went into industry and actually got a job, it was really cool to firstly see alums from this team working alongside me on the teams that I was working on, which was very cool. And it was also awesome to see some of the skills and knowledge that I'd learned from this team actually translate and be applied and used in the real world in a real engineering job.
What was your engineering job, if you can talk about it?
Yeah, so I was working at SpaceX. I was a high voltage power systems engineer.
Oh, cool.
And so a lot of the same high voltage stuff and electronics, high power electronics stuff was very applicable there.
Would you say you got that from being on an FSAE team?
Absolutely, yeah. Actually, my manager was also on an FSAE team. He was on an IC team. He was on USC's IC team, and he was like, "Oh yeah, it's always great to have FSAE alums because you can kind of know that they know how to actually do practical engineering, and they have all these skills, and they work with building things and designing things, testing and debugging every single day."
That's what we love to hear.
Yeah.